Hey guys, what's up? Welcome to the last video for this unit, and this one really is kind of just doing some problem solving. All right, we're going to get some real world problems, and we're going to work on drawing a model. We're going to work on writing an equation, and then solving, and then seeing if that answer makes sense. Okay, and those are kind of our steps, big steps for problem solving when it comes to just like big word problems. Ultimately, kind of identify what you have. Identify the parts of the problem, and then use a model to draw something to make it kind of visualized and make sense of it, and then write an equation, mathematical equation that would help you solve it, and then find out if your answer is reasonable and does it make sense. Okay, so our first problem here, we're going to do this one, and this is probably the only one we're going to do, is about Philip. And we're going to have, let's read it, and we'll highlight some stuff, and then we'll go. So let me get a color here. Let me get myself set up. All right. So Philip wants to run a total of 3 miles each day. Monday morning, he ran 1 7/8 miles. Good job, Philip. How many more miles does he still need to run? Okay, cool. I see this part right here. I see how many more. Many more usually tells me that we're going to do some subtraction. Many more. Equals subtraction. That's awesome handwriting up there. My apologies. I also see here I have 3 miles, and I see down here I have 1 7/8 miles. Okay, so step number one for us is to draw a diagram that represents this problem. And they call them bar diagrams. I call them tape diagrams. Either way, draw what looks like a piece of tape or a bar here. Okay, and this is going to represent our hole. And in this problem, the hole that we have, the big number, the hole, is going to be this right here, this 3 miles. So this whole thing is going to be 3 miles. That's what he wants to run in a course of a week. And on Monday morning, he ran 1 7/8. 1 7/8 is a little more than 1.5. It's going to be about right here, about 1 7/8. If this is 0 and this is 3 here, and this would be 1 and this would be 2, it's less than 2. And I'm just putting that on a number line. I'm just thinking about proportions when I'm making this. Don't worry too much about it. 3 miles will be the whole thing, and he ran already a total of 1 7/8. And this right here, this part is what I want to find out. How much does he have left? Okay, this right here. We'll call this n. We'll call it n for a number. That's the number that we want. Okay, cool. So this is our diagram. And that's what it looks like. That's what it looks like. What equation can we write? Well, the whole thing is going to be, we could write 3 minus 1 7/8 is going to equal n, our number here. You could also think about it in terms of this plus this equals 3, right? 1 7/8 plus n equals 3, all right? Either way, we're trying to find out what the n is, and this part right here is going to help us get there. So this 3 minus 1 7/8 is what we want to do. When we do this problem, as we look at this problem, we're gonna solve it, and then we'll see if the answer makes sense. 3, it's like I have to break that down. I have to break that up. If you remember, if you've used the tool in here where you are able to make the fraction strip, and then you can smash it with a hammer and break it up into the little bits. That's what we need to do. We have three whole bars here, and we need to be able to break them up into fractions. Okay, so if you think about this in terms of this, if I were to draw it out, actually, we have our 3 1s, 1, 1, and 1. And I need to take away 1 7/8. So I can go ahead and I can just cross off 1. But I need to be able to cross off 7/8. And I can't do that when those are all 1s. So if I'm thinking about this in terms of that, this needs to be turned into 8ths, right? And so I'll draw 7 minus 2. I need to turn those into 8ths. And then I can come and I can cross away. I can take off 7 of those 8ths. So I need to take one of my guys here. I need to take one of these full bars, and I need to turn it into 8ths. So I'll take one of them away. If I take one away, that leaves me with 2. And the one bar, the one strip that I'm going to turn into 8ths is going to be 8/8 because I have all of them. It's a full strip. It's equivalent to 1. 8/8 is equivalent to 1. And 8/8 is equivalent to 1, and 1 plus 2 is 3. And that's it. So I'm not messing with this. I'm just renaming it. I'm making it look different. So now I have 2 and 8/8, and I need to subtract out 1 and 7/8. And if I'm looking at my picture here, I already subtracted out one of those, and I'll take away 7 of 1, 2, 3, 4, 5, 6, 7 of those 8s. And we can do that thinking over here as well. 8 minus 7 equals, there's only 1/8 left over. And 2 minus 1 is 1. And we can see that represented here by this one here and this guy here, which is our 8th. And ultimately over here I also have 1 and 1/8. And so I have a number here. That number does represent something, though. It represents miles. And so how many more miles does Philip still need to run? I need to, if I have a word question, I should put it into a word answer. And so I'm going to write that down here. I'm going to write, how many more miles does Philip still need to run? He still needs, please forgive my handwriting here, to run 1 and 1/8 miles. Period. Awesome. Now, the last step for us is to ask ourselves, is this answer a reasonable one? Does it make sense? The best way we can do that is by rounding and estimating and thinking. 1 and 7/8 is almost like 2. Okay, so I'm basically saying 3 miles, and I'm saying this is almost like 2 miles, and I'm going to get something like 1 mile left over. My answer was 1 and 1/8. Yep, it's reasonable. Sounds about right. As you're getting on to problems like this next one here, where you do have several things that are going to be going into this, you still do the same thing. You're still going to just put your original bar, which is the hole. A landscaper uses this many tons of pebbles, this many tons of polished pebbles, and this many tons of river pebbles. What's the total weight of the pebbles? And this tells you there's 3 different components, 3 different parts. There's the sunburst pebbles, the black polished pebbles, and the river pebbles. And all of them are the total weight of all the pebbles, okay? And you can use this to kind of visualize and help figure it out. So use the tape diagrams, try and ask yourself what makes sense, what's reasonable, isolate what is used. Try and find those keywords to tell you, like this here, total weight. Total is adding, right? Use those words, those keywords to try and tell you which operation you're going to be doing, and just do your best. All right. Remember to try something. Part of problem solving is to think about what I know and what operation can I do, and try it, and then ask yourself, did that seem right? All right. So good luck, and I'll see you the next time. Bye.